In class, we discussed some of the basic operations that you can perform on matrices rows. Today we're going to look at how we use those basic row operations to solve systems of equations. To begin, go ahead and solve this system of 3 equations and 3 variables, and enter your answers into the Edmodo quiz. When you're finished, restart the video. Hold on to your notes from that previous example, as we're going to use the same one. We're just going to solve the system using a matrix instead. To write the matrix, we're going to use the coefficients from our 3 equations. We're going to organize them by variable vertically, and we're also going to include the constant coefficients on the right-hand side. If we did that for all 3 equations, we would get the matrix at the right. Notice that we've used all of the coefficients. We have 0 placeholders where a variable doesn't show up in the particular equations. This matrix is of the order 3 by 4, meaning 3 rows and 4 columns. It is an augmented matrix because we have the constant coefficients separated by a divider. It's also in what we call row echelon form, which is characterized by this descending stair step of leading coefficients. Row echelon form is defined by 2 main criteria. One is that any row that has entirely zeros would be at the bottom. We don't have one of those in this particular matrix. And that all entries in a column below a leading entry are zeros. So the leading coefficient in the first equation is 2. All entries below that are 0. The leading coefficient in the second equation is 1. All entries below that are 0. Some folks also require that row echelon form have all leading coefficients of 1. In our matrix, you'll notice that we have that in 2 of the equations, but in 1 we have a leading coefficient of 2. So I performed a simple row operation, replacing row 1 with 1/2 times row 1. So we get a different set of coefficients, but now we have a leading 1 in each of the leading spots. I'm fine with row echelon form not having leading 1s, but being able to get leading 1s is a skill we need to be familiar with in order to solve systems using matrices eventually. Here's a matrix that represents a 2-equation, 2-variable system. It is in row echelon form. What I'd like for you to do is to solve this system. Find x and y and enter those x and y values into the Edmodo quiz. The nice part about row echelon form is that it always gives you one of the solutions in the last row of the matrix. Well, another form called reduced row echelon form will give you all of the solutions. Like regular row echelon form, any rows with all zeros need to be at the bottom. This time, every leading coefficient must be a 1. That's why we need to be comfortable making those leading coefficients 1. Besides those leading coefficients, every other entry in the matrix must be a 0. A matrix in this form is very easily solved. With a leading coefficient of 1 and all of the other coefficients of 0, we get 3 equations: x equals -1, y equals 2, and z equals 3. The idea moving forward will be to take any matrix, perform simple row operations until you get to reduced row echelon form, and then you have the solution to your system. So let's look at an example. We've got a 3-variable, 3-equation system here. We're going to write it as a matrix, move it to reduced row echelon form to solve. So at first, pause the video right now and write out this matrix, making sure to place any zeros in the place of variables that you don't see in a particular equation. Once you've written the matrix, restart the video. This is what your matrix should look like at the beginning. Remember that 0 placeholder for the y variable in the first row. Now we're going to perform some simple row operations to turn this into reduced row echelon form. Like most systems, there are many different ways that you can solve this, but there's some strategies that make reducing to row echelon form a quicker and easier process. Generally speaking, I like to start up in that first row, top left column, if you can, take advantage of any leading ones that you already have. In this case, the y and the z leading ones, they're there. We just need to turn some of these into zeros. So I'm going to start with the first row, and I want to create a leading one in the first row, first column. To do so, I'm going to replace the first row with 1/2 times the first row. 1/2 times 2 is 1. 1/2 times 0 is 0. -6 times 1/2 is -3. And -10 times 1/2 is -5. So our new row 1 has a leading 1. The other two rows will remain exactly the same. We'll carry those along until we change them. Now my next goal is going to be to get some zeros underneath that first leading 1. This is going to be a very similar step as you've performed using elimination in systems of equations. I'm going to multiply the first row by -3 and add it to the second row. At the same time, we're going to multiply the first row by -2 and add it to the third row. Remember, these calculations will replace the current row 2 and row 3. So row 1 will remain the same, 0, -3, -5. But we'll have to do some calculations for each of the second two rows. So -3 times row 1, that's -3 times 1 plus row 2. So -3 times 1 is -3, plus 3 is 0. -3 times 0 is 0, plus 1 is 1. -3 times -3 is a +9, plus -2 is +7. -3 times -5 is 15, plus a -4 is a +11. Now continuing with the new row operation for row 3, -2 times 1 plus 2 is 0. -2 times 0 plus 2 is 2. -2 times -3 plus 1 is 7. And -2 times -5 plus -2 is +8. Now that we have a leading 1 and all zeros in the first column, we're going to move over to the second column. You'll notice that we do have our leading 1 in the second column. We have a 0 above it. Now we just need a 0 below it. So again, we're going to work on this third row. We're going to say -2 times the second row plus the third row. The first two will remain the same. The second one. Now the third one, we're doing a row calculation. -2 times 0 plus 0 is 0. -2 times 1 plus 2 is 0. -7 times 2 plus 7 is a -7. And then -11 times 2 plus 8 is -14. When we move to the next slide, I'm going to perform one more row operation. Notice that we have a -7 leading coefficient in the final equation. I'm going to divide this equation by -7, and so we'll get a leading 1, and then we should have -2 as its constant coefficient on the right-hand side. That change will happen as we move to the next slide. By doing that, notice that we have leading 1s doing the stair step. We have all zeros below those leading 1s, but we still have a couple of non-zeros above our last row's leading 1. So we need to do a couple more row operations on rows 1 and row 2 to get rid of those two coefficients. So for row 1, I'm going to take row 1 and add it to 3 times row 3. That's to eliminate the -3. To eliminate the 7, I'm going to take R2 and I'm going to subtract 7 times row 3. So the first and the second are both going to change. Row 1 plus 3 times row 3. So that's 1 plus 3 times 0 is still 1. 0 plus 3 times 0 is still 0. -3 plus 3 times 1 is now 0. -5 plus 3 times 2 is now positive 1. In row 2, same thing, row 2 minus 7 times row 3, so that's 0, minus 7 times 0 remains 0. 1 minus 7 times 0 is still 1. And now 7 minus 7 times 1 is a new 0. 11 minus 7 times 2 is negative 3. The third row will remain the same, 0, 0, 1, and 2. Notice that our matrix is now in row echelon form. Given this matrix in row echelon form, go ahead and enter the values for x, y, and z into the third question in your Edmodo quiz. Now it's your turn to take a matrix of the order 2 by 3 and reduce it to row echelon form and solve it. Remember, the strategy that we used before in a 3 by 4 matrix was to start by getting a leading 1 in the top left-hand corner, whether that's by moving a row, dividing a row, or maybe even adding a row. Once we have that leading 1, then it's very easy to get zeros above and below it by performing some row operations. Once we have that first column taken care of, then let's look for the leading 1 in the second column. Again, that would be in the second row as well. After you have that leading 1, then you can start eliminating some of the coefficients above, in this case, and or below in future cases. Once you've solved this system, go ahead and write the two answers for x and y into the Edmodo quiz, and you're finished. We'll continue to practice using row operations to reduce a matrix into reduced row echelon form in class the next time we meet.